Problem 52 from chapter 22. An electron is accelerated eastward at 3.4 multiplied 10 power 9 meter per second square by an electric field. Determine the field magnitude and the field direction. So in this question, we have to answer two questions. The first part, we are going to find the magnitude of the electric field, and in the second question, we are going to find what is the direction of the electric field. So let's rewrite the given first. What is given in the question? In this question, they give the acceleration of an electron. So what is the acceleration of the electron? The acceleration of the electron is 3.4 multiply 10 power 9 meter per second square. So only one information is given, but the question needs the information about the charge of the electron. So better we can write the charge of the electron as Q. So its value is 1.6 multiply 10 power minus 19. So here we have to use the negative value for the electron, and the unit is coulomb. And then we need the mass of the electron. The mass of the electron takes the value of 9.11 multiply 10 power minus 31 kilogram. So these two constant value we need in this question for finding the magnitude of the electric field. So now what I'm going to do, I'm going to draw the direction. So we take the direction here. This is the east direction, and the left hand side is the west direction, and the top one is the north, and the bottom one is the south. So here what they give in the question, you have an electron, and this electron has an acceleration in the eastward direction. So in this direction you have the acceleration value here is 3.4 multiply 10 power 9 meter per second square. Now by using this, we are going to find what is the direction of the electric field. So we already studied this information in the theory. What we studied, if you place an electron in the electric field, the electron will experience the force opposite to the direction of the electric field. So from the diagram itself, you will get the answer. So that means your electrical field direction will be in the left side, right? Because why? Because we are just choosing the electron. So when you place an electron in the electric field, the electron will have an acceleration opposite to the direction of the electric field. That means what is the direction of the electric field? The direction of the electric field is westward direction. That is the answer for the second question. But anyhow, first we complete the first part. So for this, what I'm going to do, I'm going to write the equation for the definition for the electric field. What is the definition for the electric field? The definition for the electric field, E, which is equal to F over Q, right? So here the force is nothing but the Newton's second law. So I have to write M multiplied by A divided by the charge of an electron. Now I'm going to substitute the value for the mass of an electron, which is a constant, which takes the value 9.11 multiplied 10 power minus 31, and the acceleration value is given in the question as 3.4 multiply 10 power 9, and the charge of the electron is minus 1.6 multiply 10 power minus 19. So here I got the answer for the electric field, E, which is equal to negative value of 0.01936, and the unit is Newton per coulomb. But here we take the magnitude. So here the magnitude of the electric field, we just consider only the positive value. So 0.01936 Newton per coulomb. So this is the answer for the first part. That is nothing but the magnitude of the electric field. But what is the direction of the electric field? The direction of the electric field, from the diagram itself, you have the meaning, you have the answer. So if the electron is accelerated in the eastward direction, means what is the direction of the electric field? Because all the time the electron behavior is having the acceleration opposite to the direction of the electric field. So your electric field direction is westward direction. So your electric field will be moving in the westward direction. So what is the answer for the second question? The answer for the second question is the electric field direction is along the westward direction. Or if you want to give the answer in terms of x-axis and y-axis, let's we take this is the positive x and the left hand side is negative x. So you can give the answer in terms of the axis also. Either you can give the answer in terms of westward direction, or the electric field is in the negative x direction. So both answers are correct. Clear? If you want to give the answer in terms of the direction wise, westward direction, no issue. But in axis wise, if you just want to give the answer in terms of negative of x direction, that is also the answer for the second question. So you can use either one of the answer in B part. So this is the answer for this question. That's it. Thank you.